అది ఎస్సీఓ స్టాండింగ్ కాబట్టి దాని ప్రాబ్లం
అంతే. Yeah, online shows. Is my voice is loud and clear? Yeah, guys. Sorry for the delay. I have traveled directly from the client office. The client office located at a high-tech city, and from there I have came directly. Unexpectedly, due to the heavy traffic on the way, I didn't expect that much of traffic on the high-tech city road today. But unexpectedly, due to the heavy traffic, it was too much delay. That is the reason for the delay of today's class. Okay, done. Now, let's get into the next one. Is today's topic we are going to discuss the last topic of our agentic AI. Based on the, we are going to work on the land graphs. So let us discuss what is land graph and how to work with the land graphs. Okay. When compared to, okay. So earlier we have executed from the agentic AI. Using the agentic AI, first we have completed by order we are having this Microsoft AutoGen. And from there we have completed by using the Pythonic AI. How to create by using the Pythonic AI any agent. And next we have discussed the Crew AI, that is framework, Crew AI framework, where we can integrate the multiple AI agents. This is the third one which we have discussed in the agentic AI. Okay, within the agentic AI, how to develop everything. And next we have discussed in the last class how to have the MCP servers and how to execute using the MCP servers and how to integrate MCP servers by using the Cloudy desktop. Okay, directly by using the Cloudy desktop. And second, by using the Cursor ID. Okay, Cursor ID. So in this entire one, though Pythonic AI, Crew AI are not the part of our syllabus also, still I have added, as you know. And MCP server also, we have discussed how to create the MCP server. Okay, we have discussed the code, how to create the own MCP servers. And that MCP servers, whatever we have created, how the tools, that is nothing but tools. MCP servers, within the MCP servers, the tools. And from the tools, how we can integrate that one and how we can use the cloud desktop or Cursor ID, all these things. So we have discussed all this in the previous class, right? So we have seen here MCP tools we have seen, and at the same time we have seen the MCP host. Like Cloudy desktop, we have taken as an example of MCP host as this one, and Cursor ID also we have considered as MCP client. So using the client, tools, and host, that is by using these three, we have created the MCP servers. And in today's class, we are going to discuss the next topic related to land graph. Okay. Now land graph is comparatively, when compared to this land graph, when comparatively, when you are comparing with the MCP servers, or when you are comparing with the this normal, what we call it as any agentic AI workflow. What are the agentic AI workflow you are having, like Crew AI or Microsoft AutoGen? So when compared to these things, the land graph is more simplified. Okay, to understanding point of view, it is more simplified. So clearly, we are going to understand the step-by-step process. And here I'm going to explain you the first the theoretical part, then followed by practical part. Okay. And as one of the student is saying that voice is not audible, others, could you please confirm, is my voice is loud and clear? Vamsi is saying that voice is not clear. Others? Others, could you please confirm? Okay, done. So only for Vamsi it is not clear. So Vamsi, relog in once. Okay, Vamsi, please relog in once. Done. So coming to the land graph. So within the land graph, it is a agentic AI workflow. Okay, in order to have this agentic AI, so agentic AI workflow, it is very simple of kind of workflow where we can create the some kind of what we call it as this algorithm. Okay, what are the algorithm? Algorithms will have, right? Flow chart. The word I have forgotten in a flow. So what are the flow chart? Generally, by seeing the flow chart, how we'll understand the entire program. For example, there is a program. For the given program, if you are having some kind of flow chart, by seeing the flow chart, how we can understand these concepts very easily. In the same way, in the land graph, we are able to understand that one. So it's kind of in the ML, if you remember the decision trees, in the within the ML, we have discussed that decision trees, where in the decision trees we are having the nodes, and each node is yes and no. And based on that, again, we'll have the one more node, and again, it will be classified to the further nodes. Right? Do you remember this kind of nodes concept and connections, all these things in the ML, decision tree? Similar way, here in the land graph, it will depend on the simple graph. By seeing the diagram itself, we can understand. In that way, it will be very simple. Okay. So now, for example, here you are having the different types of works. Let's take some kind of works you are having, multiple types of works you are having. So what are the different types of works or tools or something you are having? For example, let us take, okay, you are having the work one. Okay, that is first, the user is going to give the input, and from that the next sorry, this is what and one more, you are having the tools, different types of tools are there, and different LLM models will be there. If kind of web search, it has to connect to the web search and it has to extract the data. Like yesterday, the tools and web search will be connected to each other and they'll share the information, right? So like this, we are having the different types of functions or work or something. So now, what are the works are different we are having? All these works connecting each other is nothing but our land graph. Okay. Sir, even in the Python DKI, in the this autogen, everywhere we have done the same only, na? Remember the Python DKI, first, what we have done here, tools we have created. After that tools, what we have done, we have created the agent, create agent. And in the agent, we have given the tool. Along with the tools, we have given our model. What are the LLM model is there? The model we have provided, right? Now come to the crew AI. In the crew AI, what we have done, we have created the multiple tools, and we have created the each agent with the task, what are the task it has to do. And finally, we have created the in the main, what are the crew.py file is there. Within the crew, we have integrated, what we have integrated the different tools. That is, what are the tools we have created? The tools are nothing but agents, along with the what are the task it has to do. Okay, tools, agent, task, and LLM models. So the tools you have integrated in the agents, tools you have integrated in the agents, agents you have integrated in the task, and the task you have integrated directly in the LLM. So one is connected to other is connected to other is finally connected to the LLM model. Like this, we have created our crew AI. If you open the crew AI nodes, you'll observe clearly. Now coming to the MCP. Yesterday, what are the cursor ID we have used? And within the cursor ID, or whether it is in the cloudy desktop, directly the JSON file we have integrated. That is very simple. Now, when we have created from the scratch, so what we have done, first we have created the tools. So what are the tools we have created means, like some that is add, multiply, and one is web search related tools. And after that, what we have done, we have taken the models. Tools and models we have taken, and finally we created the agent, create agent. So one will have the one function, but finally create agent only. So that exact the function name may not be the create agent. Like in the Python DKI, only agent. The function name is called as agent only. Directly from the Python DKI, import the agent, and we are going to create the agent. So in this crew AI, we are having the create agent. In the MCP server, we are having the option called as create agent. Inside the create agent, what we have done yesterday, tools we have given and model we have given. So these tools will be connected to each other and they'll interact to each other. And finally, the final information will be given to the model and the model will give the output, right? These are all the works on the same logic. Everything will works on the same logic. Agentic AI is works on the same logic. Okay. The only difference is the syntax. The way of syntax and one after one companies are different. Okay, like in the classification project, we are having the different classification algorithms. Finally, everything are going to classify only. Classify the output only. But that classification will be done by the different algorithm in the different way. The way of execution is different, but finally everything are going to do the same kind of classification. So in the company, whether we are going to use a crew AI or whether we are going to use the MCP server or whether we are going to use the land graph, any one we are going to use. We are not going to use all of them. Finally, everything will do the same thing. Like you are having the mobile phone, and in the mobile phone, how you are having the different companies, that's it. Final, the work is same. Whether you create the what are the tools you have created yesterday, whether the same tools will not work in the crew A or in the crew A, what are the agents are done by can create in the MCP server. Both is same only, na? Whether you have created here, it will be used there. Whether you have created there, it will be used here. Okay, is the point is clear, guys? Everyone? Yes or no? Now, in the land graph also, we are going to use in the similar way. These are all the different companies only. Okay. So what are the in the crew A you have done? Yesterday I asked you to create the task. How many of you have completed the task? In the crew A, what are the agents you have created? That agents have worked as the MCP server, right? Perfect. One student from offline says that they have executed successfully. Others? Others? Jesus Khan. Have you executed? In the Kazar ID, have you executed the crew A agents? What are the agents you have created in the crew A? Have you executed in the MCP? Executed successfully? Executed successfully? Khan? Yes, perfect. Nice, guys. Perfect. So, whatever you have done, the agents created there, you can execute in the MCP. Whatever you have created in the MCP, you can do in the crew. Absolutely, there will be no difference. Okay. Uh, Sir, we can focus on any one thing for interview and we can keep the same in the interview and the resume. 100%. That is your choice. That is your choice. You can go with the MCP server and you can keep only the MCP servers and you can simply say that I can create the agents, I can connect the agents by using the MCP server. That would be easy for you, miss. Go with only single one. Just having the general idea. Now, what is the difference between the Hugging Face, OpenAI, and the Volamo models? We have completed LLM concepts and Gen AI for almost so many months we have done now. Now, what is the difference you have observed? If I ask a simple question, what is the answer? Dharmendra, if I ask a simple question, what is the difference, miss? So now, if you remember, okay, if you remember in the, yes, different companies, that's it. Now, if you remember, we have executed the image captioning project. Image captioning project means from the given image, we are going to give the caption or we are going to give some text. Text will be converted to image. Using what we have done that one. Gradio is the final deployment. Development was done with what models? Hugging Face. During the Hugging Face, I have completed that one and followed by OpenAI and using the OpenAI, we have converted. In the Hugging Face, I have used the text summarization project. Sentiment analysis, text summarization. These things we have done in the Hugging Face. Text to image, image to text, audio. These things we have done in the OpenAI. Now, can't we do the text to image in the Hugging Face? Or text summarization we can't do in the OpenAI? So these projects can be done in that. That projects can be done in this. Just These are the different types of models. That's it. So if you understand this basic logic, now today's what are the land graph we are going to discuss in the same way. Okay, once I show you the land graph and what is the concepts and everything, land graph will be very simple. So generally everyone will ask that, sir, land graph can be completed in 1 or 2 classes. That is that much of easier. Means if you are having already the basics of everything, previously these many multiple agentic AIs, you are having the idea. So this will take less time. This is the first one. Means, for example, I'm starting first time only land graph. This is my first class of agentic AI. And in the agentic AI, first topic only land graph means automatically it will take more time. Which are the first topic is that the first topic will take more time. Why first topic will take more time is from the scratch we have to start. Whereas or even in the classification also, logistic regression, KNN, those has taken more amount of time. When compared to random forest and boosting techniques, they have taken less amount of time. Why? Because here I no need to explain for you the hyperparameter tuning. I no need to explain what is meant by accuracy. I no need to explain for you what is meant by decision tree. I no need to explain for you what is meant by misclassification rate. All these things I no need to explain. First one I'm explaining the boosting. You don't know what is meant by classification. First time only I'm explaining. Then I have to start with the what is decision tree and how it will be classified. What is meant by root node? What is meant by stump? And why it has to be considered like that? All these things I have to explain. So when you are having the previous concepts idea, the additional concepts, advanced concepts will be less amount of time. Okay. Now let us get into the land graph. In the land graph also, I'm going to create the tools. What is meant by tools? User defined functions. I'm going to use the model. Models are. One model means one model, multiple from here to another one has to be given. From there, another one has to be given means multiple models automatically. Either single model or multiple models. Similarly, single tool or multiple tools. Done. Finally, what you are going to do? You are going to integrate. For example, single model you are going to consider. Let us take only single LLM model. Okay, sir, you'll get a suddenly doubt. When I'm explaining the model or models means suddenly you'll get a doubt. Sir, could you show one example with the 2 models integration? Obviously, in the today's class, I'll show you the 2 models integration also. Multiple tools along with the multiple models also I'll show you. So that you will get the clarity on that also. Okay. Once the tools are there, model is there, then what we are going to have? Create agent. And in the create agent, we are going to use this, what are the tools we are having? The tools will interact to each other. And the tools, what are the output is that the output will be shared to the model. And finally, the model will be the final output. Same logic. What is the difference between this one versus this one means nothing. Here you have imported the fast MCP. Here you are going to import from the land graph. There fast MCP, here this one. At the rate of MCP.tool, here at the rate of land graph.tool. Same logic. Okay, once we discuss this one, you will not find any kind of difference. Okay, slight difference is there, guys. Slight difference is there. I'm not saying completely zero. As I'm clearly saying now, mobile phone to mobile phone, they have to be, for example, Oppo mobile is there. In that, what are the dimension, what are the shape, what are the pixel, megapixel camera, what are the batteries there. Same thing will be as it is will be replicated in the Vivo. Okay. Vivo or MI or someone. Okay, let us assume that Oppo, what are the dimensions and what are it is having? Astis was copied by the MI. But MI, if copies Astis perfectly without changing the minute thing, what happens? It is called as copyright issue. So obviously they have to do what? Slight modification they have to do. Their battery is 6,000, 5,000 mAh means these people will create a 5,050 mAh. Now modification is completed now. It is a new mobile. Slight modification also modification only now. So like that they will just modify something. And these people will use Sony IMX sensor means one person will use the different sensor. But 50 megapixel will be the common. Inside the sensor they will change. These people will use the display, whatever display screen is there na, by one company, these people will bring that same display from another company and they'll say that I have not copied from you, we have created separately. But as it is, the mobile will look outside as it is Xerox copy. Twins only. Both of them side by side, if you keep, they are called as twins. But internally, slight changes will be there. Okay, otherwise it is called as copyright issue and it is going to be a big problem. Now, here in the land graph, we are having the different types of functions. And what are the different types of functions are there? Everything. Now I'm going to draw a flow chart. Understand this logic, guys. For land graph, because as I've told you, land graph will be, for understanding visualization, it will be very clear. In the entire ML algorithms, decision tree will be very clear for visualization purpose. We are going to write one condition, which are the record satisfies that condition comes on the right side, which are the condition not satisfied, it comes on the left side. That type of easy visualization, the graph is there now. In the same way, in the land graph also, the visualization will be very easy because they have integrated as a flow chart. So I'm going to explain that one in an easy way. Let's understand. So for example, first you are going to have the user input. Some user input you are going to have. Assume this is nothing but query. What are the, for example, in the weather forecast, the user is going to provide the input as string. Output is also string, something. Now this, what are the query you are having? This query is your planning. You are having some plan. So what we have to do? That is nothing but task. Planning, or which is also called as simply task. Okay. So what are the tasks it has to do? Simply we can say planning means nothing but task. What are the exact work it has to do? Right. Now here in this, I'm going to take a next one is, do I require any kind of web search or not? That is the question. So next one is, do I need web search? Do I need any web search for this? Okay, for completing the task, do I need any web search? For example, yes, required. So generally how we'll write in the flow chart, this one, whichever the condition is there, conditions generally will write in the diamond shape in the flow chart representation. Normal one normally will represent whichever is having the condition yes or no, that generally will write in the diamond colored box, diamond box. Normal one, normal box, rectangular box. So here I'm going to write, do I need such? If answer is yes, yes, I require the search, then it is going to connect to the API, web search API, like Airbnb API, DuckDuckGo API, or what are the APIs are there? What are the search? So we are going to have the web search. It is connecting to that. Now, for example, I don't require. Yes will be, no will be there now. If not required. Not required means web search is not required for that task. For example, in the Yahoo Finance is there. For Yahoo Finance, we are going to use the web search. No, directly integrated module we are having in the Python. So integrated module means it is going to open the, we have imported Y Finance, if you remember. Right? So what are the Y Finance we have imported? That particular Y Finance, directly what are the output we have received? It will be given to our MN LLM model. That, see, I don't require the web search. So since I don't require the web search, directly it will given to the LLM model. If you remember, two things I have explained. One is Python KI. In the Python KI, whether API we have taken, that will work with the internet or not. I mean web search or not. Means it is going to connect to the web search. Web search means it is going to go to the weather website of API. And from there, it is going to collect the information and it is going to give me the output. Whereas in the Yahoo Finance example, it is not going to use any kind of web search. Directly, it is going to give two options, both the options. Now, what are the both the options I am having? So yeah, either web search is there. From the web search, if this is the output, where it has to give to the task. Okay, what are the task is there? It has to go to the task. What are the information it has given? That it has to go to the task. Okay, if or directly If it is web search, the output should be given to the LLM. This is better. Either from web search means from the web search it has to give the LLM. If it is not web search also, directly the information has to be given to the LLM. For example, from the LLM, instead of directly giving the output, what I'm going to do is here I'm going to validate that one. What are the output I have got, whether this response is correct or wrong, something I want to validate. So I'm going to use here Gemini API, like Gemini Pro is there now. So something like something XYZ means literally to say one more LLM model, something. Okay, where it is going to check whether the response is good or not. Response is good or bad. What are the response I have got? The response is good or bad. If the response is bad, where it has to go again to the back to the task. Directly it has to go to the task. Means what are the question you are asking? The question, the response you are not going to get in a proper way. This is not the correct one. Correct response you have not received. For example, this is no. When the response is not correct, it is going to go back to the task. When the response is correct, directly it is going to end. Simple. This is only the same thing now. If we have executed in the crew A, anyone? It is not the same, sir. It is different, sir. Just anyone wants different, miss, please tell me. First, you think the weather API. In the weather API, what you have written? Tool you have written. In the tool, what it will do? First step of Python DKI. In the Python DKI, what you have done? Tool. In the tool, what it is going to do? It will take the city name, type of the weather, temperature. These things, we are going to give the input as string. Output is going to be the city name, temperature, and the type of weather. And whether it requires any kind of web search? Yes. So it is going to connect to the web, what are the API we have given. And from that API, what are the information is there? Finally, it will go to the LLM model. And that LLM model directly will give the output. If here we have not applied the whether the response is correct response or not, we have not checked with any other model. Second model we have not given. Directly the model was given with the output only. Other than this, now it is clear. Earlier whatever we have executed. So this is one LLM model. This is one LLM model in order to validate yourself. Whether the output was given is a correct response or wrong response. Or, sir, instead of this one, could you explain in a simple way? Still more simple way? Okay, let us try in the still more simple way. Okay, I will create one more workflow. This is my workflow where I'm going to get the user input. User input, that is nothing but it is going to take the information, and from that it is going to have the task, and this task will be connected to the tool. What are the API or web search is there, miss web, non-web, miss non-web. It will connect to the tool, and from the tool it will get the information, and what are the information was received, it will be given to the LLM model, and LLM model is going to give the final output. Is that fine? This is okay. This tool interaction only is called as agentic AI. Connecting to that particular tool, that is only nothing but agent. AI agent means nothing but connecting to the tools only, right? This is okay for everyone. Could you draw this diagram? First, you are going to start. This is called as start. And this is called as end. These words are important. In the land graph, start word, end word is important. Everyone has drawn the diagram. This what we call it as workflow. Generally, we call it as flow chart. What are the diagram we generally draw like this, after this, after this, after this. This in ML we call it as pipeline. Within the ML we call it as pipeline. That is order of the first step is this one, second is this one, third one is this one. We call it as ML pipeline in ML. In general, we call it as flow chart. In here in the land graph, we call it as workflow. Workflow. Okay, pipeline. project methodology, all these are same. The terminologies are different, but meaning is same. The order of execution. In simple way, we call it as order of execution. So within the line graph, what is this is called as workflow. Okay. So just to be, I'm going to use the words workflow wherever I'm going to work in the line graph. Meaning is same. Okay. Tools are nothing but user-defined functions. Technically, here what they are called as tools. Basically, we know tool means nothing but user-defined function. It is going to connect to that particular function. It is going to call that function and it is going to give the input and it will take the output. That is simple. In simple words, we call it as calling the function and using the function. But in the agentic AI, what we call it as name as tools. And that tools are connected to each other is called as agent. Without our human intervention, automatically it will only connect to each of them and they are going to work automatically. They are called as agents. Basically, these technical words only differ, but content wise, it is everything is simple, right? Now, so by using the line graph, okay, by using this line graph, what are the line graph we are having? So by using line graph, okay, we can build, we can build these kind of workflows. These kind of, what is this kind of means? Earlier you have drawn the diagram na, above. These kind of workflows. So these kind of workflows, what are we have designed very easily. We can design them very easily. Okay, easy to understand, easy to work also. Okay, this is point. Next, second. So in simple words, what is land graph? If anyone asks us what is land graph means, land graph is a framework. Like MCP server, what are the framework we are having? Crew framework we are having. It is also one type of framework that let us that will let us to organize let us to organize okay, let us organize our code. What are the code we have written? Our code into a graph, into the simple into this kind of graph type workflow, graph type structure, graph type structure, which will be created the entire program into a graph type structure, which is called as workflow, where 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 we can run where we can run this workflow, where we can run the workflow, where we can debug this one very easily. Debug is easy. And even we can share the workflow and share the workflow. Easy to share. Share the workflow. What are the workflow is the workflow. Okay, where we can run this workflow, debug the workflow, and along with the share the workflow. Okay. So it is a simple type of this one. Yes. Now, earlier, what are the diagram you are having? Okay, have you drawn this diagram? Before to this diagram, one more workflow have you drawn? In that workflow, we have written the if some condition we have written. Do you require this one? Yes. If yes means this one, no means this one. Like this we have written now. Can't we design this one by using the while loop with the break? Obviously, loop means break will be there, right? While loop along with the if and else. So first to go here, if this is the case, do this one. From there, come back to here. Again, do this one. Again, do this. If this is the case, do like this. Can't we create like this by using the while loops and if simple if and else? Basically, our agentic AI, what are the backend code of our agents are there? Na? In the backend code of the agents, we'll have simply called as, okay. Yes. So within the agent backend, the code is nothing but while loop with if and else. So instead of having the multiple while loops, so whenever you are using the while loops or if and else, the program will look as complicated. So the program will look as complex. So because nested will be more. Inside this one, inside that again this one, inside that again this one. Like that you are going to have the nested. So whenever the nested loops, nested ifs will be there now, automatically the program will look like more complex. So this complex program shortcut they have created as the agents. Basically agents will work by using the loop and if and else only. Is the point is clear? Now, exactly what is the difference between the lang chain versus lang graph? Lang chain is used for the Gen AI projects whenever you want to generate the content, whereas lang graphs is agents. Okay. So if you want to work with the agent, you want to create one agent and the agent has to execute automatically the codes and it has to give the final output. Means whenever you want to create the agent, then you have to go with the lang graph. I don't want the agent. There is no agent, there is no tools, then nothing means, then you have to go with the lang chain. Simply to say, lang chain is working with the Gen AI projects, lang graph will work with the agentic AI projects. Leela, is your question is clear? Now, next, coming to the next one is in the lang graph, within the lang graph, now we are having the different components. Okay, like in the MCP, I have discussed the various components like MCP host, MCP client, and what is the third one? MCP server. So MCP client, MCP host, MCP server. Like that, how we have discussed. Here also we are having the different components. So in line graph, we have the first one, we call it as nodes. What they are called as nodes. In the Python code also, we have to write the node only. Once I explain the theory partner, after that I'll show you one Python code. By seeing only, you'll understand everything. That much of simple it will be there. Okay. So the first one is nodes. Sir, what is meant by nodes? Nodes are nothing but functions, your tools. What are the functions are there? You are going to have the functions which are nothing but tools. Simple. Nodes means nothing but functions. Functions where it is going to execute the code. Okay. Second, we are going to have the next one is called as edges. The second technical word is called as edges. Edges are nothing but connecting the nodes. Use it to connect the nodes. Use it to connect the nodes. Okay. Now, assume guys. Okay, first my requirement is like this. First, I have to take the user input. That user input has to be connected to one tool. And from that tool, the data has to go to the model. And the model has to give the final output. This is my requirement. This is my requirement and final output I have to get. That output, for example, LLM model, whatever it is giving, either it has to be displayed for me or either it has to store in the database. Assume it was stored in the database or something. Okay. Now I want to create the tools for this. Nodes. The first node. How I am going to start with the first node means my first node is going to be the input. What are the input is there? A function. I am going to create one function, a user defined function, which will take the input and what are the output it is going to give. Right? For example, in the weather API, string is the input is what? String. That is city. What is the output it is going to give? Temperature. Next, location. And followed by type of weather. Right? So like this we are going to have. So simply we are going to take here input and what is the output it is going to give. So my input is string, output is also string. Means literally to say my first function which is used for the user input. This is my first function. Okay. For collecting the data. Next, it has to be connected to the tool. What is meant by tool here? So input is city name. In the weather agent, in the weather agent, remember that weather agent example. First, we are going to give the city name. The city name, where it will go? In the Python DKI, where it will go? The moment I give that one, first where it will go? To the weather API. And from the weather API, it will connect to the weather API. That is nothing but a function which is going to connect to the tools. Function related to tools. Okay. After going to the tool, once it goes to the tool, and from the tool, it will extract the output. Now that output, where it has to give? To the LLM model. So now next function is LLM model. Okay, LLM model. Earlier example only, the each rectangular box is called as node, guys. That's it. Earlier example on no difference in the difference. Same example as it is. Okay. Or earlier, what are the diagram you have written? Man? Go with the same diagram. Why to confuse unnecessarily? User input. User input will go to the task. And this particular task will connect to the tool. And what are the tool is that tool will give the output. And this will give the final end. That is final output you are going to get from here. Or it will give to the LLM model. And my LLM model will give the final output. Okay, this is the only diagram you have written. Any difference? Right? Now each box is called as tool. This first box, user input, is called as node. The box is called as node. The user is going to provide the input, node. It will go next task is a node. Next tool is a node. Next LLM model is a node. Next final output is a node. Whatever your final output is there, the output is node. Nodes are there. How many nodes are there here? 5 nodes are there. Connect each node. This is only called as edge. The connector is called as edge. So this one, where it has to go? This has to go directly to here? No. Where it has to go? To this one. It has to go to this one, and this one has to be connected to this one. And from again, it has to give the output like this. It has to be connected to this. It has to be connected to this. Is the point is clear? So the connection, this is A. From A, it will go to the tool B. From the tool, it will give the output C. And what are that one is there? LLM model. Or, so why to give back, sir? Directly I will connect to this one. Okay, connect to this one. It is called as C. From here to here, it is called as D. So now how many connectors are there? 4 are there. The 4 connectors are called as 4 edges. They are called as edges. Okay, the technical name they have given as edges. Each rectangular box is they called as, technical name was given as node. Box is called as node. Arrow marks are called as edges, which is going to get connected. Okay, which one after which one? And finally, the third technical word we are having is called as state. The third technical word is called as state. So this state only will take the information from one of them. It will share the information to the second one. Okay. So here node is there. Na? For example, this is the node. Again, I'm going to explain slowly what is the meaning of state. State, I told you, input it is going to take. Some input. Okay. Input, obviously, it is a function, right? Every function will have every node is a function, basically. So when it is having something it is going to take means something it will give the output also, right? Obviously, whether it is a tool or whether it is LLM model or whether anything will take some input, some output. Everything is some input, some output now. So every state will have the input output. So first it is going to have some input and this will give the some output. This output is only input of the second state. That output of that state is the input of the next state. Like that, everything. State means a function which has the input and output. That was stored inside the node. Name was node. Inside that, what will have? State. Now, sir, it is slightly getting confused, sir. Okay, I'll try to show you with a simple example. Okay, let us take everyone write like this. Draw this diagram. Start. From here, it has to go to the chartboard. And the chartboard has to give the output. That's it. Only 3 nodes. This is a simple diagram. Draw this diagram, everyone. Simplest to simplest. Input will be given. Yeah, Leela Krishna. I'm going to explain that. Draw this diagram. I'll explain with the state. Start, chartboard, and output. This is input basically. Okay, draw like this. Input, chartboard, output. Means inside the chartboard, you are going to provide the input and the chartboard will give the output. Simple. Very simple one. Okay, input and you are going to get the output. Right? Now, this is called as start. This is called as end. Now tell me, in the start, that is node. This is the node now, starting node. Start node, chartboard node, end node. Now, start node was connected to which node? Start node has to be connected to the chartboard node. Chartboard node has to be connected to the end node. Only two things. Nodes are 3 are there, connections are 2 are there. Clear? Anyone? Any doubt? No. Now, this one is going to take one input. Whatever the input is there, it is going to take one input. For this input, one output will be there, right? Every function will have some input and some output. Yes or no? Some input and some output. And whatever the input is there, that input will be given with the output, and that output will be given to the next one. So, for example, you assume you are the one person, I am one person, third person, 3 persons are there. You, me, other, 3 persons. We 3 of them are friends. You have shared some information to me. That is output of yours. Output of yours is input for me, right? Sentence only you are going to say like this. Today we have completed the land graph theoretical part. That is the sentence you have used. For you, what is that one? Output. Because you have spoken. That is output. I have listened. For me, it is what? Input. For you, output. For me, input. Now, I am going to give the same information to the other person. Obviously, right? Understood now? Every person will have the one input and one output. Understood? So, similarly here also, every function will have the one input and output. What are the output of this one is the input of the next node. What are the output of this one is the input of the next node. What is the output of this node is final output. For that, next one is not there now. Connection is not there, right? Understood, guys? Yes or no? Do you remember the ANN neural network? In that, what are the neurons will take? It will take some information, process the data, it will share to the next one. Similarly, this one also, each of them will take the input, process, give to the next one. It will take the same thing, it will process and it will give the next one. It will take the same thing to as it is here, it will pass. This node will process and it will give the final output. Input, process, output. Input, process, output. Input, process, output. Like that, every node will do the same thing. It will collect the information, process the information, share the information. Point is clear? That sharing only is called as state. The technical name they have given is called as state. Now, in the state, within the state, means every node will have the state. This state will be there, this also will have the state. Every node is a state only. State is nothing but what input it is going to take, what output it is going to give. Input and output. In every node, input and output. Node means basically state. And how these states are connected to each other. Okay. And finally, we are going to run what the graph is there, graph.run. And inside the run, we are going to write the state only. State means what are the function is there, that one. It is going to run that. Point is clear now? Now let us try to understand with a small code. Now just I am trying to open the land graph here. Okay. So here the land graph. What are the land graph is there? It is a balance agent control with agency. So design the agents that are reliable, complex task with the land graph. Means simple. In a simple way, we can connect each of them. Connection is very simple. Representation of connection is very simple. Now, I'll show you with a small example here. I'm just clicking on the docs. Okay, so it is going to redirect to LangChain. First, I'm going to click on the products, and within the products, first I'll click on the land graph, and within the land graph, I'm going to click on the read the docs. Now, so land graph is a very low level and focused entirely on the agent organization, means how it is getting connected. Okay, so here the orchestra is very simple. That is nothing but where you are going to connect the multiple agents like this. Now, first, as we know, we are going to use the pip install land graph common. The first step is we are going to install. Now, after installing, okay, I will try to show with a simple example, quick start. Okay, so first, this is your model. Okay, init chart, that is initialization of the chart model, and you are going to use the cloudy model. We are having the different types of model. You can use the chart grok also here, or you can use in terms of grok models, or you can use OpenAI models, or anything. That is your choice. Okay, so here if you are interested, you can use the cloudy also. Now, what are the model is there? And this is the tool 1, and this is the second tool 2, 1 and 2, and this is the tool 3. Okay, now multiple tools. These are the 3 different tools, that is add, multiply, and divide. These are the tools. Now, here we are going to create the state. One concept called as state. So what is the state is going to do means, it is going to take the one by one, append. It is going to append the one after one. First you have called one, and that output will be stored. Again, it will be calling one. Again, it will be stored like that. So appending will be done every time. Now, here I'll show you with a simple example. I told you now. Let me show you with a simple example. Even this much of complex is also not required. I think this one also will execute, but just I'm trying to show you with a simple one. Okay. Now, can you see here state graph, message state, start and end. So we are going to start message state is state graph. What are the state graph is there? That is first we are going to add the node. And after adding the node, start will be connected to which one? This is the edge. What is meant by edge? So here the first node. What is the first node, guys? Add node. What is the node? LLM. Okay, this is the one. Now, edge. What is the edge? What are the start will be connected to this LLM? What are the start is there? The start will be connected to the LLM, and LLM will be connected to the end. That's it. Here there is nothing is there. So 2 edges are there. Directly you are going to start, and directly you are asking the hello world. The content was given as hello world, and for that hello world was went into the LLM model, and LLM model will give the output as hi. Simple. Understood or not? So for example, okay, I'm going to take here. Simply I'm writing hello. I have not written any question, just I have written the hello. What is it going to say? Something. So this hello directly went to the LLM model and it has given the output. That's it. This is a simple one. Start directly went to the LLM model, and LLM model has given the final output. Completed. And here the role is user, and what are the question input they have given is hi. That's it. So this hi has went into the LLM model. LLM model has given the output. Nothing is there. Point is clear. Understood or not? Yes or no? This is not the chatbot, guys. Not even chatbot or anything. Okay. So what is node? Add node is you are going to add the node. That is nothing but this one. What is add edge? Add edge means this one. Which one has to be connected to which one? First, edge has to be connected to the which node to which node? Start node to the LLM. LLM is this one. Start node has to be connected. What are the start is there? That has to be connected to the LLM. LLM has to be connected to what? End. Compile. Compile means this is the land graph. And invoke. Graph dot invoke. In the invoke, what is the user is going to provide? Content is hi. Now this hi will be given as the input, and it will go to the hi to the LLM model, and it will give the output. That's it. Simply, you are going to, for example, in the OpenAI model, just if you have imported OpenAI model, and if you give the hi, what is the output you are going to get? First OpenAI model. Do you remember, guys? Could you open your OpenAI first code? First code of OpenAI. If you don't remember, I'll try to open here. Your first code of OpenAI. This is not even agentic AI, guys. Don't worry. This is not even agentic AI. Just base to the base, just to understand how this land graph code is, that just to show you. Okay, this is not even agentic AI also. Now see here in the OpenAI first class of OpenAI, when we have discussed, okay, directly we have loaded the model. And after loading the model, for example, if you have written here, hi, what is the output you are going to get, guys? Tell me. This is our first code in the OpenAI. Do you remember at least that one? Okay, from OpenAI, import OpenAI and client.response.create, and the model you are going to give, what are the model? Hi. And directly it is going to give the output. Do you remember this one? Yes or no? If you give hi, what happens? Hi will be given to the model and it will give the output. That's it, right? Is there anything else? Anything else? So for example, here, if you do you remember this course we have executed? Here I have written the hello, how are you? It is going to give the message that, hello, I'm just a computer program. I don't have the feelings, but I'm here to ready to help you. How I can assist you today? For what question it has given? Question is, the user has provided the question, hello, how are you? For that question, this is the response. Just it went to directly to the model and it has given the output. This is the simple code, right? So just here from OpenAI, just we are going to import the OpenAI, and the OpenAI, just we are going to give the chat completion.create, and we are going to give the input and it is going to give the output. Very simple, basic to basic. The same thing will be done here. In this, what are the land graph example is there? The role is AI, content is hello world, and I'm going to import this one, that is user, and this is the question. My question is this one. This question will be given to my LLM model. What are the LLM model I have selected here? And for that LLM model, I'm going to get the response. That's it. Here you have not given the still the LLM model name. If you give the LLM model, this hi will go to the LLM model and you will give the output. Understood the logic or not? Yes or no? Everyone, please confirm. This is the basic one. That is the reason I asked it to draw the diagram. Draw first diagram. This is the question. Hi. Hi is the question. This question was given to my LLM model, and LLM model has given me the output. This here, whatever you have written, that is the input given directly to LLM and output. This same thing, there we have written like that. Here we are going to add the nodes and add the edges. This is a graph type representation. Same thing as it is. If you are more interested, even you can use that particular, state. What is this? Everything I'll explain. The code I'll explain. Here, just you have to focus on the what are the input was given. The input will be given to the particular LLM node, and that LLM node will give the output. Clear? Now that model, even you can choose the OpenAI model. So here, just now I have opened this code now. In this, if you write here hi, if you write here hi, if you write hi for this particular model, what is the output you are going to get? Or you have written here, hello, how are you? You have written now. For hello, how are you? What is the output you have got? This is the output, right? This is the output. Same output as it is if you are using the same model, 3.5 turbo, same model if you are using in the land graph, same output you will get when you have entered here, hello, how are you? Same output. Just I am showing you how that basic code was converted as a graph node inside the land graph. Point understood now? I have not explained you for this, what is this state, what is this message state. I didn't explain anything. Just I am showing you the connection. After the connection, compile. Compile means the entire one will be considered as single and the workflow. Compile means workflow. It will be considered as workflow. Now in the workflow, what are the input you are going to give here? Based on that input, it will give the output. Now we'll try to connect the agents. Inside this, now let us try to connect the agents. Earlier we have not connected the agents. Now let us connect the agents and let us see how these tools will be interacting each other. From the tool, how it is getting interacted and how we are going to get the output. Okay, is the point is clear, everyone? The main core components and the graph and everything is clear now. This is only main code. Node means exactly in the each node you are going to write the tools, and this node has to be connected to this one. That node has to be connected. Edges is nothing but connections. First you create the nodes. This is node 1. Assume here I am going to write node 1, node 2, node 3, node 4. Okay, this has to be connected to this one. This has to be connected to this one. This has to be connected to this one. What I am going to write? First I'll write the node. Each 4 nodes I'll write. After that, edge. Inside the edge, I'll write the first edge. The first edge is node 1 has to be connected to the node 4. Second edge, node 4 has to be connected to node 2. Third edge, node 2 has to be connected to the node 3. As per my diagram, what order is that one? First I have to create the 4 nodes. After that, I have to create the edges. Connection is completed. After connection is completed, compile. After compile is completed, now you are going to invoke. Inside the invoke, you are going to give the input. That's it. Fixed code. Is that clear? Simple? Yes or no? So tomorrow we are going to do from here. I'm going to create the nodes, and how you are going to connect the nodes, I'll show you with the Python code. Okay? We'll take some tools and we'll try to connect the tools. Tomorrow we are going to complete the land graph with an example by using one kind of chartboard. Some kind of chartboard example let us create by using the land graph. Yes, please share today's notes. How I have to share? I mean, I have written only in the notepad. Nothing is there now. Diagrams, majorly I have drawn the diagrams. Every diagram is manually I have written. They cannot be shared. Can we cover the human in loop chains and adding the memory in the workflow? Absolutely. Yeah, Abhishek. So what are we have written from here to here only? Take the screenshot. This is only now. Other than this, nothing. What are we have written is nothing. Land graph is comparatively very simple for visualization point of view, understanding point of view. Coding point of view, we have to write the nodes separately, states separately, and connections separately like that. Code wise, it will be lengthy. Understanding point of view wise, it will be easy. Okay, guys. So tomorrow we'll continue and we'll end the land graph tomorrow. Okay, we'll try to do one project in the land graph tomorrow. Sir, it is because of main.py present inside the MCP file, which you didn't share. For rest of the 3 files, code was similar. No, there is nothing in the main.py. Main.py is automatically by default when you have initialized the UV, na, automatically main.py will be there. So you have got the same answer. Others has got the perfectly right. Livy, how many days are there to Sagar? Others has got perfectly. There is nothing in the main.py. I have confirmed with the other students just now. They are saying that they have received, they have executed successfully without any kind of problem. They have even integrated that through AI agents also. Livy, you tell me, still how many topics are there? Langgraph is the last topic, right? Is there any other topics are left? Check once. Livy. So as per the content, course content, what are the topics are there? We have completed that. And additionally, only we have done. And as per the course, we have discussed a number of projects. Additionally, only we have executed. Apart from the ML. ML projects, ML separate now. Okay, done. Thank you, guys. Obviously, right? Obviously, tomorrow will be the last class apart from ML. ML will be day after tomorrow. Yeah, in this, okay. Ravi, in the Google Drive of for 6 p.m. batch and 7:30 p.m. batch, the ML, the drive is same only. The drive link is same. What are the drive link of them and for you the same drive link? Could you open your drive link once? It is the same. Yeah, Chetan, can you connect with the mentor once tomorrow? Or I'll try to share you the main.py. Since you are feeling that main.py is having something now, I'll share even that. Cross check once. What's wrong in that? Let's cross check. Okay, done.